So let's begin by reviewing the individual parts of a logarithmic function. A logarithmic function has three parts: the base b, the argument x, and the power y. Now, why is y called the power? It is because the logarithm, which is y, is the exponent the base b needs in order for the term to have a specific value of x. Now, before we dive into the particulars of the structure of this function, let's begin by reviewing how we articulate this function here. You can say it a number of ways. You can say the log of x with the base of b is y, hence why we're calling it the logarithm here instead of the power. You can also say the log base b of x is y. Those are two different ways you can express this function. Structurally, here's what's happening. The log of base b of x is y is equivalent in exponential form of taking this base b, its raised to a power of y, b to a power of y, and that equals the argument, which is x. So we see we'll have two different forms. We'll have logarithm form and we'll have exponential form, and that is the relationship between the two. Again, in logarithm form, we have our base b, and this can be raised to a power of y, and that would equal x, and you convert that to exponential form. We'll be using this relationship throughout the entirety of this chapter, so feel free to refer back to this point in the video whenever you feel it's necessary. Now, in logarithm form, the base b will be greater than 0 and not equal to 1, which will result in the argument x being greater than 0. So if the base b is greater than 0 but not 1, when we raise it to a power, that means x will be positive. So we will not have an argument that is negative, but we'll dive deeper into this property later in the chapter. Just remember that our base is going to be greater than 0, but not equal to 1, and that will result in x being greater than 0. We will not have a negative argument. So now that we have a basic understanding between the relationship of logarithm form and exponential form, let's walk through an example of how we go about evaluating or solving a logarithm in which we are given the base and the argument. So you'll be asked to solve for y, and let's say you had log of base 3 of 9, and that's equal to y. How would you solve for y here? Step 1, you want to convert the function to exponential form. So how do we do this? We take our base 3, raise it to a power of y, and set it equal to 9. So we have 3 to a power of y is equal to 9. And now we want to multiply our base 3 times itself until the product is equal to 9. So how many times do we multiply 3 times itself until we get 9? The answer is 2. 3 times 3 is equal to 9. So since we're multiplying 3 times itself twice, that lets us know the exponent y is equal to 2. And if y is equal to 2, that lets us know log of base 3 of 9 is equal to 2. So the logarithmic function is telling us how many times the base must be multiplied times itself to have a value equal to the argument. So that is how we go about solving for the power of a logarithmic function. Let's now have you try a few practice questions. Solve for y. Question number 1. Log of base 4 of 16 is equal to y. Question number 2. Log of base 2 of 16 is equal to y. And question number 3, log of base 5 of 125 is equal to y. Pause the video, answer these questions, and then press play when you are ready to begin. Question number 1. We were given log of base 4 of 16 is equal to y. Step 1, convert the function to exponential form. So we want to take our base 4, raise it to a power of y, and set that equal to 16. And now step 2, we want to multiply the base 4 times itself until the product is equal to 16. And we know that 4 times 4 is equal to 16, which means we multiplied 4 times itself twice, letting us know the power y is 2. So we find that the log of base 4 of 16 is equal to 2. That is the answer to question number 1. Let's now have a look at question number 2. We were given log of base 2 of 16 is equal to y. So step 1, we want to convert the function to exponential form. So we take our base 2, raise it to a power of y, and set it equal to 16. And now step 2, we want to multiply the base 2 times itself until the product is equal to 16. 2 times 2 is equal to 4. 4 times 2 is equal to 8. And 8 times 2 is equal to 16. So we find that we have to multiply the base 2 times itself 4 times, which lets us know the power, or the exponent, is equal to 4. So we find that the log of base 2 of 16 is equal to 4. That is the answer to question number 2. Let's now have a look at question number 3. We were given the log of base 5 of 125 is equal to y. So step 1, we want to convert the function to exponential form. So we take our base of 5, raise it to a power of y, and set that equal to 125. And now step 2, we want to multiply the base 5 times itself until the product is equal to 125. 5 times 5 is 25, and 25 times 5 is equal to 125. So we see that we have to multiply the base 5 times itself 3 times, letting us know the power y is equal to 3. So we find that the log of base 5 of 125 is equal to 3.